So the product rule helps us when we've got functions multiplied by each other. The quotient rule is when we have functions divided by each other. And so you get this wonderful expression here. You can see vu dash minus uv dash over v squared. Square the bottom, write down the bottom, diff the top, minus write down the top, and diff the bottom. There you go. Square the bottom, write down the bottom, diff the top, minus write down the top, diff the bottom. Let's have a look at an example. So x on 1 plus 2x. Okay, I could rewrite that as x, 1 plus 2x to the negative 1 and use the product rule. I mean, that would work. But the quotient rule makes it a little bit quicker. Square the bottom. So the bottom of the fraction, I just simply chuck some parentheses around it, squared. That's done. Now everything else happens on the top of the fraction. So write down the, square the bottom, write down the bottom. So there's 1 plus 2x. Diff the top, well that's just 1. Minus, write down the top. Diff the bottom, we get 2. And so that tidies up to just be 1 on 1 plus 2x, all squared. So square the bottom, write down the bottom, diff the top, minus write down the top, diff the bottom. 2 on the square root of x squared minus 4. Whoops. Square the bottom, I get x squared minus 4. Write down the bottom, x squared minus 4 to the power of a half. Diff the top, 2. Minus, write down the top, 2x. Diff the bottom, but I'm going to have to use a chain rule to do that. So bring down the power, lower the power, diff the inside. And then tidying that, what do we got? We've got an x squared minus 4 to the positive a half and a minus a half over there. So that factorises. There's also a common factor of 2. But x squared minus 4 to the negative a half, well, that means that's on the bottom of the fraction. So I can put that on the bottom, and we get our final answer there. Okay. Now, the reciprocal rule. This is a special rule between me and you. You won't find it in any textbook. Okay? It's for a specific case when you have the constant on the top of the fraction. So that's why we call it the reciprocal rule, because if it was just 1 on the top, 1 over reciprocal. That would be the formal solution. It's simply minus the derivative on the function squared. So 1 on x squared, sure, I could put that in index form, x to the negative 2, and do it that way. Or I can simply go minus the derivative on the function squared. Minus the derivative, well, it's got to be of the bottom of the fraction because the top's a constant. And differentiate a constant, you get 0. So when we say minus the derivative, it must be of the bottom of the fraction in this case. So that's minus 2x. On the function squared, well, square x squared, I get x to the 4. The x's cancel. There's minus 2 on x cubed. Okay. 6 on 4x squared plus 3. So minus the derivative, but in this case we'll multiply it by 6 as well. And then on the function squared. And so you get minus 48x on 4x squared plus 3 squared. So that's when you have a constant on the top. It just saves you. I mean, the reason it works is if you did the quotient rule, you would have gone square the bottom, so you'd still get the square the bottom, write down the bottom, diff the top. Well, the top's a constant. So whenever you differentiate a constant, you get 0. So that whole thing's going to be 0. You're going to be left with minus, write down the top. Well, that's just the constant, diff the bottom. So you'll always end up with minus the derivative on the function squared. Okay, so 7G, our quotient and our reciprocal.